In the previous session, we introduced the idea of stoichiometry and completed a couple of problems using the idea of stoichiometry. Let's just do a few more so that you get more practice. And as I said this before, this is best learned by doing it on your own. So please do as many problems as you can. There are several examples at the end of the chapter as well. There's a worksheet that is posted on Canvas for you to attempt at, and plus of course there is the homework as well that needs to be done. Okay, so here's another problem. Please pause the recording while you read the problem, while you understand the information given and what needs to be calculated. So in this question, we need to calculate the volume of water that can be produced in this reaction from the combustion of 5.50 liters of ethyl alcohol. So in other words, we are in this question given the volume of ethyl alcohol, let's call ethyl alcohol A, and we are asked to calculate the volume of water that can be produced from that volume of ethyl alcohol given this reaction. So once again, I hope that if you are using this picture, you're only using it to figure out the path. So volume of ethyl alcohol can be converted into mass of ethyl alcohol using density. That can be converted into moles of ethyl alcohol using molar mass, converted to moles of water using coefficients in the balanced equation, to mass of water using its molar mass, and finally to volume of water using its density. So since we have all the information that we need, we now need to get started with the problem. Now, what is the first step in any stoichiometry problem? Exactly, a balanced reaction equation. Unless you have that, you cannot start, and the equation has to be correct. So please remember, we're talking about a combustion reaction of a compound that is made up of CHNO. Now, I expect you to always remember this, that when such compounds undergo combustion reactions, C2H6O, they react with oxygen gas in the air and produce carbon dioxide and water. This is expected for you to know. Now, once you have the equation written, then we go ahead and balance the equation. So when you balance this equation, hopefully you would get 1C2H6O, 3 oxygens produce 2 carbon dioxides and 2 water. Let's just make sure that this balancing is correct before you move on. Oops, excuse me, it's not 2, sorry, it's not 2 H2Os, but should be 3 H2Os, so that you have 6 hydrogens on both sides, and then we have 7 oxygens, 2 times 2, 4. Yes, so we've got the balanced equation. So once again, we start with what's given that needs to be converted. Please focus on that. The densities are not, that is the goal here. The density is going to be used as a tool, not as the data that is being converted. What is being converted is 5.50 liters of ethyl alcohol. That's the data that's given. So since the density of ethyl alcohol has volume in units of cc, our first job is to convert liters into cc through milliliters. Liters, so we have cc's of C2H6O at this point. Now we can use the density of ethyl alcohol, which grams C2H6, sorry, I did that wrong. Okay, grams of C2, something's H6O to Cc, which will cross out Cc, give us grams of ethyl alcohol. Grams of ethyl alcohol can be converted into moles of ethyl alcohol. Moles of ethyl alcohol can then be converted into moles of water, because that's what the question is in context to, and moles of Moles of water can be converted into grams of water using molar mass of water, and then that can be converted into volume using the density of water, which is given in grams per ml. So at the end of this calculation, the unit we'll be left with is mLs of water. That is an appropriate unit for density. Unit for volume of a substance. Now let's go ahead and put in the numbers. We know 1 ml equals 10 raised to minus 3 liters. We know 1 cc equals 1 ml. From the density of ethyl alcohol, we know 1.029 grams of ethyl alcohol equals 1 cc. 1 mole of ethyl alcohol has a mass of 46.08 grams. This is the molar mass of ethyl alcohol, and I hope everybody remembers how to calculate that. From the coefficients in the balanced reaction equation, we know that 3 moles of water will be produced from 1 mole of ethyl alcohol. Molar mass of water is 18.02 grams, so that goes there. And then finally, density of water is given as 0.999 grams of water for 1 ml of water. So these are the values that we put in each conversion factor, and then finally when you calculate, we get 6.640257973 times 10 raised to 3 mLs of water. Since the question does not specify what unit of volume should the answer be given in, we can leave it in mLs, but if you wanted, you could convert it into liters or gallons or anything that you fancy. I'm going to leave it in mLs because the question doesn't really specify anything. The answer does need to be rounded to 3 significant figures based on the data given, and therefore the answer becomes 6.64 times 10 raised to 3 mLs of water will be produced from 5.50 liters of ethyl alcohol using this reaction equation. Okay, so let's try out this problem as before. Please pause the recording. It's actually a good idea to do so while you attempt the problem on your own before we work on the solution. First step, of course, is to write a balanced reaction equation, which for this reaction would be Fe2O3, that's iron 3 oxide, would react with 3CO, carbon monoxide, to produce 2 irons and 3 carbon dioxides. So I'm going to set up the first one, and I'm going to ask you to complete the rest on your own, and I'll write down my answers. Hopefully they will match. So the first one, we need to go from 3.56 kilograms of carbon monoxide, to formula units of iron 3 oxide. So first step, of course, is to convert kilograms to grams, and then grams of CO can be converted into moles of CO. 1 kilogram is 1000 grams. The molar mass of CO is 28.01 grams, so that converts into moles of CO. Moles of CO can be converted to moles of Fe2O3 using the coefficients in the balanced equation. And then moles of Fe2O3 can be converted into formula units. Formula units, please remember, is a kind of a particle, just as atoms, molecules. Formula units would be the smallest unit for an ionic compound, so that Avogadro's number goes there. 6.022 times 10 raised to 23 goes there. When you complete the calculation and round the final answer to 3 significant figures, hopefully you get the answer as 2.55 times 10 raised to 25 formula units of Fe2O3. Okay, please do complete the remaining two parts as well. By the way, that's C, not A. Complete the remaining two parts as well, and hopefully you get the answers that match mine. 0.469 liters of CO2 for that one, and 1.4 times 10 raised to 23 atoms of iron for this one. Okay, so once again, here's another example where if you read the question correctly, carefully, we are needing to calculate the mass in pounds of silver sulfide, which is Ag2S, that can be produced from these many oxygen molecules according to the reaction equation. So in this case, the reaction equation is given, but we must always make sure that it is balanced. If it's not balanced, you must do that first before anything else. So if you balance this reaction equation, we get 4 silver react with 2 hydrogen sulfide and 1 oxygen to produce 2 silver sulfide and 2 water molecules. Okay, so now if you set this problem up, we're starting with what the data that needs to be converted. That is the number of oxygen molecules. So oxygen molecules can be converted into moles of oxygen using the Avogadro's number. Crosses out. Moles of oxygen can be converted into moles of silver sulfide using the coefficients in the balanced reaction equation. Moles of silver sulfide can be converted into grams of silver sulfide using molar mass of silver sulfide, which calculates out to be 247.80. And then grams of silver sulfide can be converted into pounds of silver sulfide, knowing that 453.6 grams make up a pound. When you calculate this, there's one word of caution that I would like to say again. Please use parentheses correctly in your calculator, especially a situation like this. Make sure that all the numbers that need to be in parentheses are in parentheses, otherwise the calculator will see it differently. Okay. When you calculate this, hopefully we all get 37.91960343 pounds of silver sulfide, which needs to be rounded to 3 significant figures based on that number, and gets rounded to 37.9 pounds of silver sulfide as the final correctly rounded answer.